So let's start a new topic. Uh, Last few classes we discussed the in last few classes we discussed about the rock mechanics, rock formation, and then different types of minerals, etc. At this class, we will start a new topic, and that is seismology and earthquakes. So, at the very beginning of this topic, we will discuss some terminologies related to the earthquake and let's start with some terminology. The first one, and at this picture, we will try to understand the inner structure of Earth. This image is actually very well known to us. That means the outer portion around 3 to 19 miles, depending on the area, is known as the crust. Okay. Known as the crust, that means the most outer surface of the earth, and thereafter the next layer, basically main three layer. শোনা যাচ্ছে না?
দেখা যাচ্ছে না, মানে স্লাইডের যে পার্টটুকু পড়াচ্ছে ওটা দেখছি।
ওয়েট, এখন দেখা যাচ্ছে?
নো স্যার।
দেখা না যাওয়ার তো কোনো কারণ দেখতেছি না। এখন ঠিক আছে?
নো স্যার, হয় নাই এখনো।
এখন ঠিক আছে?
না স্যার, দেখা যায় না স্যার।
ডেস্কটপ শেয়ারিং হচ্ছে না?
স্যার শেয়ারিং স্ক্রিন হচ্ছে স্যার, দেখা যাচ্ছে না।
ওয়েট, তাহলে আমি লিভ করে ওকে। সো record. Okay. So the most outer layer, this is known as crust, and thereafter the more inner portion, that one is known as core, and the intermediate portion, and that is known as mantle. So in the core, core is again divided in two parts. One is the inner core, and the remaining one is the outer core. The core portion is actually contains the molten lava, hot gases, liquid, etc. And while we moving gradually out toward the surface of the earth, the temperature and will be reduced, and this portion is intermediate portion, is known as the inner mantle and intermediate mantle, these two portions, and thereafter the three portions. Actually mantle is divided in three part. The most outer one is the upper mantle. So now another discussion about our earth crust. That means we are standing or living in our earth crust, and there are many continents. There are many theories also available that in past there are only one continent, and thereafter it separated in different slices, etc. So if we consider this one, the actually the continents are moving from one to another, and in some cases not only they are going far away, in some cases two continent may merge with one another. So let's have a look on our map. So if you look at these portions, okay, so this is looking like that the east side of the South America, that means this portion is matched with the west side of the Africa. That means it's look like a two piece of puzzle. Actually, those are separated from each other. So this is actually a hints or clue that the continents are actually moving. That means in million of years ago or many times ago they are in a single pieces and then moving. The next term we discuss is the continental drift. The continental drift, this is actually based on a theory. Wagner, a scientist who believed that the Earth only had only one large continent at past, and then around 200 million years ago. According to his beliefs, this plate is then broken, just like a ceramic plate or something like this. That is broken, and then pieces slowly. These pieces are slowly moving or drifted, comparing to one another, and then it comes in the present configuration of our continental map. So so this terminology is known as the continental drift. That means this movement, and the reasons and causes behind this movement. What is the source of energy on which this movement is occurring? So the background mechanism, etc. All of these need to be known. So that's why we need to discuss another some topics, the seismograms, earthquake. We will discuss later in details. So here is an typical presentation of continental drift. That means with the change of time, how this movement is occurs. This is actually time lapse animation. So it's helps us to understand the continental drift. And now we are at present we are in this condition. So and next terminology we need to discuss. This is the plate tectonic. Sorry. The plate tectonic, according to this is another theory. According to a plate tectonic theory, the Earth's surface contains tectonic plates. That means different plates are connected to each other as the lithospheric plate, and whose plates are consist of crust. That means in Earth crust, there are many plates, rigid plates. That means those are moving, can move with respect to one another, and also there may have some sub plate. That means among one plate, there may have some other sub plates. So this is a typical view, and many of you may known to some terms. That means Eurasian plate, North American plate, Indian plate, in Australian plate, etc. when an earthquake is occurs. So it's more in scientific community, it is most commonly known. This earthquake is happened due to the sliding or movement of or in the plate boundary of Eurasian and Indian plate boundary or Arabian plate boundary. Okay, the propagation or the source of this earthquake is the Indian plate boundary, etc. It is most oftenly known. So later we will discuss details the plate tectonic, and this plate tectonic is theory. This is mostly related with the our this current topic earthquake. So here is another video how the plates are moving. Plate tectonics, that means the plate movement. So the hot molten lava, those are circulating, as those are the hot liquids. So while it's boiling, it's circulating, okay, inside the earth crust. So due to this partial circulation, it creates a force, okay. That's the circulation, it creates a force which leads to movements, such types of movements. That means one plate or one layer, geological layer, lithospheric layer, is moving compared to another one. And in this process, it is also clear that in metamorphic rock formation or sedimentary rock formation, we discussed that one geological layer may go inside the earth crust. So the question may arise, how can one layer move to the towards the inside of the earth? So from this video, this is the technique, okay. Due to this tectonic forces and the plate movement, the upper layer, so those which one is in the earth's surface, suppose in 1,000 years ago, this due to the tectonic movements, this layer is going inside the earth surface, and then it may form sedimentary metamorphic rock, or sometimes metamorphic to igneous rock, igneous to metamorphic, etc. So this is also related with the rock mechanics, as well as the in another portion of our course, madam may discuss the um, fold fault joint. Those are also interrelated with these topics. So let's have a details look about plate tectonics. Our Earth's surface consists of a number of large intact blocks that are called actually nothing as the plate, and these plates move with respect to one another. Okay, so the Earth crust is divided into 6 continental sized plates: African, American, Antarctic, Australian, Indian, Eurasian plate, and Pacific plate. So this is the major 6 continental plates, and thereafter 14 subcontinental plates are also available based on the fracture or the fault line. These are actually these plate boundaries are actually based on the fault line, among the fault line. The smaller sizes plate or micro plates, those are broken off from a large plate. That means due to the geological changes, tectonic forces, etc., the earthquake. Uh, so at the vicinity of the major plate boundaries, those are small plates or small lines are created, and thus the large plate is formed fragmented into small plates. And relative deformation, this is another topic. The relative deformation between the plates, that means as one plate is moving compared to another one, so this there may have relative deformation. These are occurred in the narrow zone near the boundaries, so the deformation is only visible in the near the plate boundaries. Later we will show some another illustrations like this, the plate boundary. So the next term is the plate boundary. That means the borderline of two major tectonic plate. This is known as the plate boundary. and propagation of major earthquakes, the maximum earthquake is corresponding to the plate boundaries. That means in the plate boundaries, the earthquake is created or propagated from the plate boundaries. So depending on the movement of the plates, there are three types of plate boundary. Okay, the plate movement actually in the boundary or borderline of two plates, the relative movements will occur due to tectonic forces, as we show earlier. Say the internal force of the Earth. So due to these forces, the movement is occurs, and based on the movement, actually this plate boundaries is classified is based on the movement. The first one is divergent boundary, second one is convergent boundary, and third one is transform boundary. So let's start one by one. First one is the divergent boundary. So these terms are in generally known to us. So, and this movement or plate boundary, this is not necessary that always this plate boundary will go through a plain land. Okay, this maybe this boundary line may remain in the uh, ocean ocean bed or river bed, or sometimes move towards land, hilly area, ocean bed, etc. It may cross along any geological position. So let's start with the first one, the divergent boundary. The term divergent means while two plates move away from one another. That means the relative movement of two plates is away from each other. Let's look at the illustration here. Due to the force, tectonic force, these two plates are trying to move away from one another. That means when the hot magma is creating uplifting force, due to this uplifting force at the neck of the volcano, or when the volcanic eruption is occurs, at those points, the two opposite the movement is occurs in two opposite direction. So who is spreading the reeds or spreading the plate boundaries, and the earthquake spreading in these divergent boundaries are relatively small and occurred in the shallow depth. The next, this is another example of a divergent plate boundaries. This is called the rifting. When these consider a divergent boundary, those occurs within a continent. If this divergent boundary is among some subplate, so within a continent, so this condition will be known as the rifting. And the molten rock from the lithosphere rises to its surface and forcing the continents to break and separate. With enough movement, the rift valley, look at this image, this is a rift valley. A valley is created which is filled with water eventually, and this formed mid-ocean reeds. Mid-ocean reeds, these types of reeds or a valley is created along the ocean bed, and this is known as the mid-ocean reeds, and the mid-ocean reeds is created due to a divergent plate boundary. The next one is the convergent boundary. The convergent boundary, this is actually opposite to a divergent boundary. In convergent boundary, one plate is moving, suppose one plate is fixed and another one is moving towards this plate. That means there is a chance of collision. That means two plates are sliding with respect to one another in vertical direction. So based on the movement, this convergent boundary is again classified in the three categories. First one is the oceanic continental subduction zone, oceanic subduction zone, and continental continent collision zone. So from this name, these types are actually Based on the name, it can be easily understand that uh, suppose for first one, oceanic continental subduction zone. That means one tectonic plate is oceanic plate. That means an ocean bed. One is oceanic plate, and another one is the continental plate. That means this one is from land portion. Okay. So and the next one, oceanic subduction zone. That means this converging will occurs in the boundary of two plates in which one is, both are oceanic plate. Okay. That means this subduction or the plate conversion movement will be occurs beneath the uh, water, the sea water. That means at the ocean bed. The last one is the continent collision. That means both plates are continental plate, and the boundary line is along the Earth's surface. And thereafter, while this is actually known as collision, because while two solid plate of Earth first move towards one another, there is a chance of collision. Okay, and due to this collision, most of the hill and most of the hill mountain, etc., these are actually created due to continent collision of the at, at, at the convergent boundary. So actually this is an first example, say oceanic plate, and the side one is the continental plates. So the oceanic plate is moving beneath the continental plate. So later we will discuss why which one will go up during this relative movement towards one another. That means they are moving each to each another, and the question may arise: why always oceanic plate is moving? Why not the continental plate is going beneath the oceanic plate? So we will discuss it one by one. The first one is the oceanic continental subduction zone. In this case, one tectonic plate, there's force beneath the one another. In generally, the oceanic plate is um, forced to move beneath the continental crust, and due to this movement, a deep sea trench is formed at the location where one plate is forced beneath another. That means during this relative movement, a trench is created uh, along the uh, fault line. And the next one is the oceanic subduction zone. This is also um, same as before, but the two plates are actually oceanic plate converging, and during this process, also a trench is formed. The most widely known trench, this term is most widely known to all of you, the Mariana Trench, for example. So this is a term noted as the fast moving Pacific plate convergent against slow moving Philippine plate. That means in this case, the formation of the Mariana Trench, the both plate is moving. Yeah, the both plate is converging, on which the Pacific plate, those is converging very fast movement, going a very fast movement compared to the slow movement of Philippine plate. Okay, so this is an example of the oceanic subduction. The last one is continent collision zone. Okay, most of the cases in mountain ranges, these types of collisions are found. So the underlying layer, like the lithosphere, is moving. So due to the movement of lithosphere, due to the internal forces of Earth, the overlying soft layers, that means as we know that with the increasing the depth, the density of layer is increased due to the overlying load. So it is very common that the surface density of the surface layers will be less, and those will be in within plastic range. That means it's a very soft and can be move or reshape. So while such types of collisions are occurs, these soft overlying layers are actually moving towards one another, and due to this collision, and the at the boundary line, at the collision line, causing squeezes of the masses. That means two solid masses, flexible solid, soft solid masses are squeezes compared to one another, and they fold, deformed, and thrusted upward. That means due to this pressure or converging forces and squeezes of the masses, the overlying layers are thrusted upwards, and due to and this upward undulations is actually visible as the mountain. And most of the mountain ranges are created due to the continent collision. Okay, and our last plate boundary, third one, this is the transform plate boundary. The first two plate boundaries, those are actually based on vertical movement. That means a relative vertical movement, and the transform plate boundary, this is actually sliding. Okay, the horizontal movement, that means side by side movement, when one plate is sliding compared to another one. And due to these types of plate boundaries, transform plate boundary or transform movement, no construction or destruction of the earth crust is occurs. That means in converging plate boundary, there may be create the mountain or trains, etc. Okay, but in transform plate boundaries, such types of geological formation is very rare. But due to this relative movement, you may found that, okay, 2 points are side by side. Suppose in nowadays 2 points are side by side. After 1,000 years before or after, you may find that, okay, these 2 points or these two countries may shift from one another in sideways direction, in horizontal direction. So this is the task of the transform plate boundary. And the next question, as we discussed last few minutes, that the movement is occurs within these plates. So these tectonic plates or earth plates, these are actually in general sense, these are actually layers, like the massive slab of solid rock. Okay, floats. So the question may arise, these plates have a tremendous weight. Okay, very dense layer, geological layers, sometimes maybe 5 kilometer, 10 kilometers thickness. So these, what is the force, and what is the technique, and which points will decide that which one will converging towards another one, or which one will go up and which one will go beneath. Okay, so this is the big question, and based on this question, let's discuss some basic terminology. First, the continental crust. Most of the continental crusts are composed of granite rock. Okay, these are made of relatively lightweight minerals such as quartz, feldspar, etc. On the other hand, the oceanic crust. This is composed of basaltic rock, which are most mass denser compared to previous one. So this isn't just a simple example, but in reality, there may have multiple types of rock, also have sedimentary rock, etc. So this is evident that there must be a variation in weight. That means And if we consider two plate moving towards one another or move, so at this point, at the point of convergence, these two plates have different weight. Okay, due to the imbalance of this weight and the density of two types of crust, this movement is occurs. So in general, the heavier one will go down, and the comparatively lightweight light layer uh, will move upward. Okay, so due to this weight, self weight of this rock, uh, and relative uh, difference in the density and weight, this movement is occurs. And the force which is dominating such types of movement, this is the tectonic forces, and the source of this force is the yeah, at the inside of the earth, due to the uh, movement of liquid magma, and this is the circulation of magma. This creates a thrust, and due to this thrust, the movement is occurs. So the next term, this is fault. Term is the fault. Fault is actually in also included in our syllabus, and we'll discuss details in another portion of these courses. So I am just discussing the basic, so that as it is required for the to understand the terminologies of the earthquake and seismology. Faults are basically the faults, very simple. It's the fracture in the crustal strata. That means in our earth crust, there is a fracture line. So this is the fault line. This is very common in the earthquake terminology. This is the fault line. And this is actually the boundary of two plate. Okay. The boundary point of two plate. That means the joint. And this is an jointing line. So this is known as the fault. And amount of displacement along the fault line, this may vary only a few tens to say a millimeter, or several hundred kilometers. So the visibility of this fault, this will actually depends on the earthquake, internal forces, types of earthquake, types of occurrence, and many things. So there are different types of fault. Different types of fault, like the normal fault, strike slip fault, oblique fault, etc. Okay, so this is actually a fault, typical view of a fault. In a fault line, along the fault, this is the cross section. That means two plates. Okay, so one plate is moving compared to one compared to another. It means slip is occurs. So along these two crust, one is moving downward, and another one is fixed. Some cases different may occurs. So along this fault line, first one, the portion or plate which is fixed, this is known as the um, footwall. And this the plate which one is moving downward, sliding, this one is the known as the uh, hanging wall. Okay, that means two wall is sliding one compared to one another. Those are actually we showed in the continental drift or conversing. Such types of movement is actually occurred. So the fault motion, this is caused by the tension force and resulted in extension. Okay, so these types of configuration is known as the normal fault. And next one, the reverse fault. Okay, so reverse fault is actually opposite to the normal fault. That means the hanging wall is moving upward relative to the footwall. In these cases, compressive force, this zone will face a compressive force. So this one is known as the reverse fault. Strike slip fault. Strike slip fault is most common, like as the transform plate boundary, as we discussed. This is an example of a strike slip fault. The horizontal or side by side movement. That means two plates from this illustration. This road is this is a straight road, but due to the horizontal movement, strike slip fault, like the transform plate boundary. These 2 points are moved away. That means in the fault motion, this is caused by the shearing force. Okay, this is caused by a shear force. And the next one is the oblique slip fault. The oblique slip fault is occurred by both deep slip and strike slip. That means both in both direction, horizontal and side by side direction. That means shearing and tension or compression. That means not only the sliding, along with sliding there is an horizontal movement also. So the combined slip, this is the called oblique slip fault. Another one is host. These types of fault is developed when two reverse fault. That means two reverse due to the movement, compressional movement of two reverse fault. The remaining block or intermediate block is moving or pushed upward. That means in such types of configuration, the intermediate portion will be pushed upward. And if the river, this is called the host and graben. And when the reverse condition is occurs, that means two fault line along the fault line, two plate is moving away from each other, and when the tensional stress result the subsidence, land subsidence of the intermediate block on a large scale. When it's occurs in a large scale, that means a valley will be created. Okay, due to this downward movement, this zone will be acts like a valley, a rift valley. So this is the graben. Here are some example of fault rupture. While after the occurrence of any earthquake, these types of features are visible, and massive destruction is actually occurs the fault line. That means while the movement is occurs, the fault line is visible. Suppose let's show another few example. Say this is this point, these 2 point. This is actually a straight road, but a fault line is crossed towards this across this road. So due to this activation of this fault line, around 5 to 4 feet is visible displacement is found. It's a normal fault. Okay, this is an example of normal fault. That means the man is standing. This is the foot wall, and the remaining one is the hanging wall. So the hanging wall is slipped along this fault line. This is an actual another example of fault, surface fault. Okay, and that means the side by side movement, and the line along the line on which the this movement is occurs. This is actually known as the fault line of earthquake. This is actually occurs in 2060 Kumamoto earthquake. Here is another some example of visible surface fault. Okay, so up to this, this is actually our some basic terms of earthquake. Okay. Thereafter, we will discuss some other terminologies. This is the actually the basic of the seismology, and then we'll discuss the earthquake. What is earthquake? The propagation of earthquake, different types of earthquake, etc. So hopefully earthquake have some other few classes may required. So তোমাদের আজকে আমি একটাই ক্লাস নিচ্ছি। আমার খুব বেশি একটা টাইম লাগবে না। স্যাটারডেতে তোমাদের কি অবস্থা?
স্যার
স্যাটারডে
স্যাটারডে তো স্যার কোনো ক্লাস নেই স্যার।
আচ্ছা, আমার হয়তোবা নেক্সট ওয়েডনেসডে হয়তোবা আমি একটু ক্লাস নিতে পারবো না, ওইটা হয়তোবা ম্যাডাম নিবে। সো স্যাটারডেতে তোমরা আমাকে একটা টাইম জানাও, যেটা হচ্ছে আমি ক্লাস নিব, বুঝছো? স্যাটারডেতে আমি 2টা পিরিয়ড ক্লাস নিব। আজকে সিঙ্গেল ক্লাসে নিচ্ছি। একটা সুইটেবল টাইম তোমাদের বলো ওই দিন যে কোনো সময়ে, তো আমি
স্যার
ক্লাস নিব। হ্যাঁ বলো।
ঠিক আছে স্যার।
আচ্ছা, আমাকে মেসেজে ইনফর্ম করলে হবে। টাইমটা ইনফর্ম করে রেখো, সবাই 2 সেকশন একসাথে। এই তো। তো ঠিক আছে, আজকের ক্লাস মোটামুটি এই পর্যন্ত। আমি স্যাটারডে 2টা ক্লাস নিব, এরপরে নেক্সট ওয়েডনেসডে আমি ম্যাডামকে বলবো ম্যাডাম ক্লাস নিতে। এরপর নেক্সট থার্সডে হয়তো বা নিতে পারবো কিনা, কারণ আমাদের আসলে একটা কনফারেন্স আছে। এই উইকটা আমাদের একটু বিজি শিডিউল যাবে, সেই জন্য আমি স্যাটারডে থেকে ক্লাস নিব। এরপরে হয়তো বা আবার দেখি না, সুইটেবল ওয়েডনেসডে হয়তো বা পসিবল হবে, ম্যাডাম নিবে। বাট এর পরের দিন নেক্সট বৃহস্পতিবার পসিবল হবে না। তো সেক্ষেত্রে আমি হয়তো বা রিশিডিউল করবো, এটা আমি তোমাদেরকে জানিয়ে দিব। আর আর্থকোয়াক হইলে মোটামুটি আমি একটা ক্লাস টেস্ট নিব। আর্থকোয়াক এন্ড সিসমোলজি যে স্লাইডটা আমি পড়াচ্ছি, মোটামুটি আরো অনেকগুলো টার্ম আছে। তো মোটামুটি এটা পড়ানো হলে আমি একটা ক্লাস টেস্ট নিব তোমাদের। আরেকটা ক্লাস টেস্ট হয়তো বা আমাদের কিছু ম্যাথমেটিক্যাল পোর্শন আছে, ড্রেনেজ বেসিন, ওই পোর্শন থেকে নেওয়ার চিন্তা ভাবনা করতেছি। আর একটা পোর্শন হচ্ছে অ্যাসাইনমেন্টটা তো তোমাদেরকে বললাম, তোমরা লিখতে থাকো। এই তো। তো আজকের ক্লাসে কারো কোনো কোশ্চেন থাকলে ডিসকাস করতে পারো, আদারওয়াইজ
স্যার
বলো।
স্যার ম্যাটেরিয়ালস গুলো একটু স্যার দিয়ে দিয়েন স্যার, গত ক্লাসেরটা মনে হয় দেওয়া হয় নাই স্যার, বৃহস্পতিবার
ক্লাসটা দেওয়া হয় নাই? আচ্ছা ঠিক আছে, আমি এখন দেখে দিয়ে দিচ্ছি রেকর্ডটা। ওকে
স্যার, ম্যাটেরিয়ালস গুলো দিয়ে দিলে হবে স্যার, রেকর্ড পরে
আচ্ছা
দিন।
আচ্ছা, হ্যাঁ ম্যাটেরিয়াল রেকর্ডও দিয়ে দিব, ম্যাটেরিয়ালস খুব সম্ভবত বাকি আছে। হ্যাঁ ঠিক আছে, আমি দিয়ে দিচ্ছি। ওকে।